The stark contrast between the billion people thriving along the Indo-Gangetic Plain and the sparse population of Mongolia illuminates a fundamental truth. Where rivers flow, human civilization follows. Agricultural productivity, the rice revolution. While rivers have shaped where populations could thrive, it's what humans cultivated in those fertile floodplains that truly revolutionized our ability to concentrate in specific regions. The Asian population circle owes much of its density to an agricultural innovation that transforms limited land into extraordinarily productive food systems. Rice cultivation stands as perhaps humanity's most efficient food production system. In Southeast Asia, a single hectare of rice paddy can sustain approximately 5 times more people than the same area devoted to wheat in Europe or North America. This remarkable productivity difference explains why regions practicing intensive rice agriculture can maintain population densities that would be impossible elsewhere. This agricultural efficiency creates stark contrasts in how many people different landscapes can support. Consider Australia's outback, a vast territory covering 70% of the continent, yet supporting merely a tenth of Australia's already modest population. The contrast stems directly from the agricultural potential each environment can sustain with available water resources. What makes rice cultivation so extraordinarily efficient? The answer lies in its multidimensional approach to resource utilization. Rice paddies function as complex agricultural ecosystems that maximize productivity from limited space. True microcosms of human ingenuity, where every square inch serves multiple purposes simultaneously. Farmers throughout the Asian population circle have perfected techniques that transform a hectare of land into a multi-layered food production system. In these integrated systems, farmers create symbiotic relationships between rice, fish, vegetables, and fruit trees, all thriving within and around the same paddy. This ecosystem approach multiplies food output while minimizing waste. Perhaps most importantly, many regions within the Asian population circle can harvest multiple rice crops annually from the same plot of land, further multiplying the overall productivity. This integrated approach stands in sharp contrast to agricultural practices in regions like Australia's outback, where harsh environmental conditions limit both what can be grown and how intensively the land can be used. The infertile soils and limited water resources create natural ceilings on agricultural productivity that technology alone cannot overcome. According to the Global Agricultural Productivity Report, the concept of total factor productivity, TFP, helps explain these dramatic differences. TFP measures how efficiently farmers convert inputs like land, labor, and materials into agricultural outputs. The remarkable efficiency of rice cultivation systems represents one of humanity's greatest achievements in maximizing TFP, creating food surpluses that allowed populations to grow far beyond what would otherwise be possible. The GAP report highlights that sustainable agricultural growth requires achieving an average annual 2% TFP growth between now and 2050 to meet global food demands. This benchmark underscores the continuing importance of efficient farming systems like those developed across the Asian population circle, which have historically delivered exceptional productivity from limited resources. These agricultural advantages don't emerge overnight. The high-yield systems prevalent across East and Southeast Asia represent the culmination of thousands of years of agricultural innovation. Farmers throughout the region gradually refined techniques to maximize output from their limited arable land, creating a virtuous cycle where increased food production supported larger populations, who could then contribute more labor to intensify production further. This feedback loop, more food supporting more people who could create even more food, helps explain why population density increased so dramatically in rice-growing regions compared to areas relying on less productive agricultural systems. Historical population growth curves show remarkable correlation with the expansion and refinement of rice cultivation techniques across East and Southeast Asia. What's particularly fascinating about these agricultural systems is how they've maintained their advantage despite technological advances. Even with modern agricultural technologies, the basic productivity advantage of rice cultivation remains. The caloric output per acre for wet rice cultivation dramatically outperforms other farming methods, even when comparing modern versions of each system. This persistent advantage explains why traditional rice-growing regions continue to support exceptionally dense populations despite dramatic changes in other aspects of society. The agricultural foundation, established centuries ago, created population patterns that have persisted into the modern era. South Asia exemplifies this continued agricultural evolution, emerging as a regional leader with an impressive average annual TFP growth rate of 1.4% during the past decade. India in particular has achieved a remarkable 1.7% annual TFP growth by investing in mechanization, information technology innovations, and optimized resource use. This success demonstrates how regions with historically productive agricultural systems can continue enhancing their advantage. The contrast with regions struggling to achieve similar agricultural productivity is stark. Sub-Saharan Africa, for instance, has recorded an average annual TFP growth of just 0.37% over the same period. Agricultural output in these regions relies primarily on land expansion and input intensification rather than efficiency gains, a fundamentally different approach than the intensive productivity model that characterizes the Asian population circle. The